Another effect we can add to our particles is to make them grow or shrink. If you're following along, I'm working in particle.as and particlegrow.fla. Both of those files are in the movie 3 folder. We're going to make our particles grow in a similar way to how we applied friction to our particles. We're going to create a grow x and grow y properties. They're both going to be numbers. Make sure to specify them as public as well. Then we'll initialize them with values of 1. So grow x equals 1, and the same thing for grow y. Then at the very bottom of our update method, we'll modify the scale x and scale y properties by the grow x and grow y properties respectively. So scale x times equals grow x, and the same thing for scale y. And we'll multiply scale y by grow y. So as the particles shoot out, they'll scale up. Let's save this file, file save, and then jump over to our FLA file. Right below where we set the initial x and y positions of the particles, I'm going to set the grow x and grow y properties. So we'll set grow x equal to 1.02, and then we'll set grow y equal to 1.02 as well. And when we test the movie, you see that they grow, then after they oh, it's really funny. You'll see that the particles continue to grow after they regenerate. So we kind of want to reset the x and y scales of the particles once we regenerate them. So I'm going to scroll down, and we're in the area where we reset the particles in the conditional statement that's within the loop in our code. We'll just set particle.scalex equal to particle.scaley. That'll be 1. We'll set them both in the same line of code there. That's fine to do. Test the movie, and the particles grow, and they shrink back to their original size once they're recreated. And you can see that the particles shrink back to their original size when we reset them. And that's all that there is to making particles grow. Now we'll make our particles fade out. We're going to do that in the same way that we applied friction and grow to our particles. If you're following along, I'm working in the particle class and particlefade.fla, and both files can be found in the movie 4 folder. So let's create a public property, and we're going to call that fade. We'll set the data type as a number, and then initialize the value at the bottom of our constructor to 1. Then what we'll do is at the bottom of our update method, we'll modify the alpha of the particle by multiplying that by fade. So if the value is a little bit less than 1, then the object would fade out a little bit every time we run the update method. And that's all that we're going to add to our particle class. So let's choose File Save, save this file, jump over to particlefade.fla, open up the Actions panel, and I'm going to scroll up in my code, and I'm going to find where we set the initial properties for the ball. And then right below where we set grow x and grow y, we'll set fade for the ball equal to 0.98. Now we test the movie, and you'll see the particles fade out. Notice that they can become completely invisible after a while, so obviously we'll have to reset the alpha for the particles. So we'll do that at the bottom of our conditional statement inside of the loop in the update stage function. We'll set the alpha for our particle for each particle that gets reset to 1. And then one thing we can do is we can check to see if the particle's alpha is less than or equal to 0. If so, we can reset that particle. So I'm going to add that to my already large conditional statement. I'm just going to add an OR operator in there, and we'll just check to see if the particle's alpha property is less than or equal to 0. That'll just be one more expression to check to see when to reset the particle. So we'll test the movie now. The particles fade out a little bit, and they regenerate and start again in an alpha of 1. So that's how to fade particles. Now that we've taken a look at adding some more realistic animation effects to our particles, let's take a look at using these effects in a real-world application. In this movie, we'll take a look at adding rotation to particles so that they rotate in the direction that they're moving. If you're following along, I'm working in particle.as and particlerotation.fla, and both files can be found in the Movie 5 folder. If you have these files, the first thing I want you to do is test the movie. I built a particle system here that has arrows, and I took away their gravity and friction properties so that we can really see this in action. So just test the movie right now. You can test it straight from particle.as. And here you can see arrows, and notice that they're all pointing to the right, but they're all moving in different directions. So our goal here is to make the arrows just rotate or point towards the direction that they're going. So the first thing we'll do here is we'll create a public property, and we'll call that auto-rotate. It's going to be Boolean, and we'll initialize it to false in our constructor. Then in our update method, we'll check to see if the value of auto-rotate is true. If so, then we'll rotate the particle based on its x and y velocity. In order to move a particle based on its x and y velocities, we need to calculate the ratio of its x and y velocities and get an angle out of that. In order to do that, we're going to use the built-in math method called math.atan2. Math.atan2 takes in two properties. First, it takes the vertical value, so we'll pass in y velocity first, and then it takes the horizontal value, so we'll pass in x velocity second. I'm going to press F4 on my keyboard to get a little bit more space for writing my code. What you really need to remember when you're using math.atan2 is to pass in y velocity first, because you naturally want to pass in x velocity first, because you typically think x and then y. But in this method, it's reversed. That's how they get you. Remember that. And then, that value that's returned by math.atan2 gives us radians, and that's not an angle that we can use to rotate an object. In order to rotate an object, we need to convert those radians to an angle. The formula to convert radians to an angle is to multiply the radians by 180 over pi. So we'll take our math.atan2 and multiply that by 180 divided by math.pi. And that's all that there is to it. So let's choose File, Save, and then we'll jump over to particlerotation.fla and open up the Actions panel. You'll notice that the code for this particle system is a little bit different than what we've done before. We have our num of particles and our particle class that represents our library item, so we can make easily transportable code. We have a particles array, a container to hold them, and then we have a timer. So we're running our makeParticles function based on a timer and not just based on enter frame event. Let's take a look at the run immediately code. We're putting the container on the stage, adding an event listening to the timer to run makeParticles, starting the timer, and then we're listening for enter frame on the main timeline and running update particles every frame. That function is very simple. It just updates every particle in the particles array. Where the real magic happens is in the makeParticles function. So let's go there. And the first thing we do is we clear the container. So anything that's inside of our container, we get rid of it, using both removeChild and the shift method of the array class to take away the first particle from the particles array. The next thing this function does is it has a loop to create particles. So along with the timer, we're creating all the particles that we want to create immediately. So we kind of get this explosion effect. What we'll have to do in here, we're going to set the particles auto-rotate property to true. Then you'll see the particles rotate along with their x and y velocities. Notice that they're appearing wherever the mouse is. Now they're rotating based on the direction that they're moving. So that's a success. The next thing we want to do is apply gravity and watch them rotate down as they move down. I have that in my code and it's commented, so I'm going to uncomment that now and show it. Notice as the particles move down, they rotate downward. That works great. Looking at the way these arrows move reminds me of something else. So what we're going to do now is uncomment this code. We're going to change those arrows into fireworks. Notice I'm simply uncommenting code that sets fade values, grow x and grow y. I'm applying a color transform to each particle, making sure to import the color transform classes. And I'm going to change the particle class to firework. And inside of the firework particle, there is another movie clip called glow_MC, and that's where we're applying the color transform. Now I'm just going to change the background to black. I'm going to need to press F4 to get all the panels back. I'll change the background to black and test the movie, and behold the fireworks. And there you have it. So there's how to rotate particles in a particle system based on the direction that they're moving.